Hello friends, in this video we will go through what is activation function and importance of activation function in the neural network. So let us see what is activation function. Activation function is a mathematical function which is applied to output of the neuron. So here you can see there is input layer and then there is weight and then there is bias. So input and weight are multiplied together and bias is added, then it is applied to activation function. So what is the role of activation function? It will decide whether the neuron should be activated or not. So the complete process is input and weight are combined, then weighted sum is calculated, then it is passed to activation function and activation function will decide the output. This is how it will work. Now next is it determines whether neuron should be activated or not. So let us see example here. Once the input is passed, then it will decide whether to activate the neuron or not. So here you can see in first example, if x is equal to -4, f of 4 is f of -4 is 0. Actually here ReLU activation function is applied. So what is ReLU activation function? It is the function is f of x is equal to max of 0 comma x. So here x value is -4. So since the value is less than 0, output is 0. So that's why neuron will not be activated. Now, if the value is positive, then output will be 5 and neuron will be activated. So ReLU activation function we'll see in upcoming lectures. But the purpose here is how the neuron is activated. It depends. It completely depends on activation function, whether to activate the neuron or not. So why do we need activation function? Let us see. Without activation function, the network remains linear. So what does it mean? It means that suppose we have a neuron calculated z is equal to w1 x1 plus w2 x2 plus b, and we do not have any activation function. The output will be simply z. Again, if there are several layers, let us say input, then layer 1, layer 2, layer 3. If there is no activation function, we can transform into single linear transformation, that is W3 into W2 into W1 into X. So it is nothing but it is linear. It is linear network. Now what happens? Uh, if there is activation function, it will check whether the output of the if output of the first neuron should be passed to next layer or not. How? This is by activating the neuron. So that is the importance of activation function. Now, what first of all, let us see what is linear network. So a linear network is a network that does not use any activation function. So in linear network, activation function does not exist. If let us say single neuron net, first example is single neuron, no activation function. So here neuron calculated W1 x1 plus W2 x2 plus B. So without activation function, the output will be simple Z. If there are again multiple layers, then if there is no activation function, you can write it as Y is equal to W3, W2, W1 into X. So here, without activation function, it is linear network, and uh, with non-linear activation, it is non-linear network. So that's why the activation function is required. It allow network to learn the complex pattern. Now, with activation function, the network can learn the complex pattern. Suppose uh, there is example of image recognition. A network need to learn, first of all, network need to learn pixel, then images, then shape, and then object. These relationships are complex and linear. So first of all, the pixel are identified, then network edges are identified, then edges are identified, then it is combined into shape. So how it is possible? It is possible through activation function. So if pixel is detected, then the neuron is activated. If edge is detected, neuron is activated. Then edges are combined through activation function. So activation function enables introduce non-linearity, enable the network to learn complex pattern from simple to advanced representation. So that's why activation functions are required. Now next is it helps to create the decision boundary. So this is very important concept. This is linear model. Okay, linear model can if there is simple pattern, you can easily differentiate. But if there is complex data or complex pattern, then it is little bit difficult. So that's why activation function are needed. So here through activation function, you can identify the complex relationship between the data points. So that's why activation functions are needed. The example is classification of cat versus dog, recognizing handwritten digits, detecting spam mails, predict whether loan is risky or not, or recognizing object in images. So it require complex patterns. So that's why of activation function is needed. Next is with without activation function, the network is linear. That is, you can simply differentiate between 0 and 1, yes or no, true and false. Then with activation function, you can find out the non-linear relationship, you can find out the complex pattern, and then through non-linearity, you can again find out the complex pattern. So activation function is the key to non-linearity, which is the key in learning. So the purpose of deep learning is to learn the complex data, to learn the complex relationship between the data, and that's why activation function are very much needed for identifying the complex pattern. So activation, where we can apply activation function, where you we can apply activation function to the neuron weighted sum. So how first of all input and weights are multiplied, then bias is added, and then it is passed to neuron. So at the neuron level, we can apply the activation function. So here and there are various activation function in upcoming lectures. We'll go through ReLU, TANH, sigmoid, step activation function. So activation function can also be applied at the output layer. It is not necessary that it should be applied at the hidden layer only. We can apply activation function at the output layer also. So activation function and output layer, we can specify, we can do binary classification. Then if there are multi-class classification using softmax activation function, using regression, multi-level classification. So using sigmoid activation function, we'll see this activation function in upcoming lectures. But the important point is here is we can apply activation function at the output layer also. So that's it for this video. I do hope you understand what is the purpose of activation function. In next upcoming videos, I will take sigmoid 10s activation function and other activation function also. So if you like the video, then please subscribe, like, and share. Thank you.